Hello everyone, welcome back to day 4 of our holiday program. I do need to check the volumes quickly because I didn't realize yesterday that the music was incredibly loud. So let me just check that everything is fine. Hello everyone, welcome back to day 4 of our holiday program. I do need to check the volumes quickly because I didn't realize yesterday that the music was incredibly loud. So let me just check that everything is fine. Okay. Today looking at exponents. Let's see. Okay. So for exponents, what is an exponent? Well, when you have something that is being multiplied repeatedly, so for example 2 times 2 times 2 times 2 times 2. This is what we call a repeated multiplication. It's multiplication of the same number every single time. So we can condense this, we can write this in a more simplified way by using exponents. So what we do is we take the number that's being multiplied every single time, which is 2 in this case, and we want to count how many times we are multiplying by 2. So this is 1, 2, 3, 4, 5 2's that are being multiplied. So that 5 will go on top over here. That is the exponent. So that 5 over there, that is the exponent. And this 2 over here, this part over here, that is called your base. So your base will always have an exponent on top of it. In high school you'll learn that every single base will always have an exponent. In this case it's invisible, but nonetheless a base has an exponent, and the exponent just tells you how many times that base must be multiplied. So why we use exponents is because obviously we can have just a very long multiplication or repeated multiplication. So instead of having to write all of this out, we can just use exponents, which is base 2, because the 2 is being multiplied over here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is going to be our exponent. So that's just going to be the number of times that 2 is being multiplied. Excuse me, my chest seems to be a bit scratchy this morning. My throat is being scratchy. So that is basically what an exponent is. It just tells you how many times that this base must be multiplied, and your base can be anything. So it can be 3 to the power of, let's say, 5. That's also going to be 3 times 3 times 3 times 3 times 3. It can be a letter. So if we take a to the power of 6, it's just going to be a 6 times. That's being multiplied. 1, 2, 3, 4, 5, 6. So the a, oh sorry, what did I want to say? Yeah, so the base, it doesn't really matter what it is. You just have to expand it using the exponent over here. That's the amount of times that you need to write it out. And this only goes for multiplication. Exponents do not refer to adding or subtracting. it's only multiplication. So you're just multiplying whatever your base is. Yes, and your base can be a fraction as well. So let's say it is a half. This half can be to the power of whatever it is, let's say 2. So this is then going to be a half multiplied by a half. And going by what we did in the week, when we're multiplying fractions, it's numerator times numerator, and denominators denominator times denominator. In this case, it's going to be 4. Now, there are some special exponents that we need to look at. Specifically, the one that has a 2 and the one that has a 3. So when we have anything to the power of 2, then obviously it's just something that's being multiplied out twice. If it's to the power of 3, then this is going to be 2 times 2 times 2. Oh, I forgot to mention, you'll hear me say to the power of. So when we want to read out this over here, we'll say it's 2 to the power of 2, 2 to the power of 3, a half to the power of 2. So it's always going to be your base. So it's going to be base to the power of exponent. Your terminology, the way you say things in math, is very important, especially if you have a tutor, or if you just need to explain to your friend, if you need to explain to the teacher. It's best that you learn the proper terminologies. Don't say this is 2 or half 2 or half and a half, or whatever the case may be. Learn this proper terminology. It's the base. In this case here, it's 2 to the power of and your exponent. So 2 to the power of 3, or 5 to the power of whatever the case may be. So to learn the proper terminology, it is your base to the power of exponent. Now these two exponents, the 2 and the 3, they are very, very special, because whenever we have anything to the power of 2, so 3 to the power of 2 is going to be 3 times 3, 4 to the power of 2 is going to equal to 4 times 4, and you'll see that it's two numbers that are being multiplied by each other, the same number that's being multiplied by each other. 5 to the power of 2 is 5 times 5, and so on and so forth. And yesterday, I obviously had the whole 5-10 minutes on just multiplication tables. Again, multiplication tables are extremely important, and these multiplication tables, well, these multiples are very, very important. So when we say 2 times 2, we're going to get the answer of 4. When we say 3 times 3, it's going to be 9. 4 times 4, 16, and 5 times 5 is 25. These numbers over here are very special in that they are called square numbers, or squares. These 9, 16, 25, 4, and obviously we can continue onwards. These are known as your squares, or more so the perfect squares. You have to know your perfect squares out of your head. It's not only going to help you now in grade 7, but definitely in high school. The squares, they are important. Similarly here with to the power of 3. If you say 3 to the power of 3, it's going to be 3 times 3 times 3. 4 to the power of 3 is 4 times 4 times 4, and so on and so forth. So when we answer these, 2 times 2 times 2 is going to give you 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. And 5 times 5 times 5 is 125. These ones over here are known as perfect cubes. So your squares and your cubes are important. You need to know them. For the squares, you want to go all the way down to 12 squared, which is 12 times 12. That's 144. With the cubes, 5 cube is fine. So you can go to 6 cube as well. 6 times 6 times 6. And that's going to be, I blanked out, 216. So just remembering your perfect squares and your perfect cubes will help you quite a lot in your exams. So as you can see with the, let's take 5 squared over here, we can work forwards and backwards. So if we are given, let's say, the number 25, we know that 25 is a perfect square. So 25 can be written as 5 times 5. And since this is repeated multiplication, that means we can write this as an exponent, which is going to be base 5 to the power of 2, because there's 2 5s over there. Similarly with your cubes, if you are given 64, we can write this as 4 times 4 times 4. Excuse me. So keep your base, which is 4, and there's 3 of them, so we can put a 3 in the exponent part. Excuse me. So that is basically the gist of exponents. In high school, there are what's called the exponential laws that you will learn. Nothing difficult, but you need to understand what an exponent is and how to determine an exponent, how to calculate with exponents, and we'll do roots soon as well. Now with exponents we can obviously do some calculations with it as well. So something like 7 squared plus 1 squared, and 7 squared would be 7 times 7, and 1 squared would be 1 times 1. So 7 times 7 is 49, and 1 times 1 is 1, which will give us the answer of 49 plus 1. So the questions that they're going to ask you regarding exponents, it won't be that difficult. I don't think they ask a lot of it either. I might be wrong, but it really isn't that difficult if you know your multiplication tables. So let's go through some other questions before we move on to the roots, to square roots. So there are 2 special cases when it comes to exponents, which is 0 squared and 1 squared. Now 0 squared, obviously squared tells us that it's the base multiplied by itself twice. So this would be 0 times 0, and for 1 squared it would be 1 times 1. Now 0 squared, because it's 0 times 0 and anything multiplied by 0 is 0, the answer will be 0. And anything multiplied by 1 will stay the same, so therefore 1 times 1 will just be 1. So 0 squared is 0 and 1 squared is 1. Actually, 0 to the power of any number, we can even make this 100. Same thing for 1. 1 to the power of, I'll even make this 1,000, will still be 0 and it will still be 1. So obviously this is going to be 0 times 0 times 0 100 times, and this can be 1 times 1 times 1 1,000 times, but there will always be the answer of 0 for for 0 to the power of, and 1 for 1 to the power of. Keep this in mind, because this is how they can trick you as well. 0 to the power of anything is 0, 1 to the power of anything is 1. Okay. So let's look at some questions. As you can see over here, we added two exponents together. We can subtract two exponents as well. So that's going to be 6 times 6 minus 4 times 4. And 6 times 6 is 36. Minus 4 times 4 is 16. And 36 minus 16 is going to give us 20. We can multiply exponents as well. So this is 5 squared times 3 squared. So 5 squared is going to be 5 times 5 multiplied by 3 squared, which is 3 times 3. So 5 times 5 is 25 multiplied by 3 times 3, which is 9. And what is 25 times 9? 100, no, 225. Here we go. And since we can add, subtract, and multiply, similarly we can also divide. So we can look at something like 8 squared divided by 2 squared. 8 squared is going to be 8 times 8, and 2 squared is 2 times 2. So 8 times 8 is 64, and 2 times 2 is 4. So 64 divided by 4. 4 goes into 64 how many times? So this would then be also, since this is division, just for interest's sake, this can be written as a fraction of 64 divided by 4. But the answer here is 16. So as you can see, we can work with adding exponents, multiplication, subtraction, and division of exponents. We can do something like this as well. Something like 9 minus 5 squared. So what we now have is a base that needs to be calculated first before we can square it. So 9 minus 5 is going to be 4 squared, or 4 to the power of 2. And we know 4 squared is 4 times 4, which is 16. They could give it to you like this. Move this up. So 2 times 3 to the power of 2. So first do 2 times 3. We can see that the square over here is on top of the bracket, which means this entire bracket over here is your base, just like this one over here. And since the base needs to do some work first, that's what we have to do. So 2 times 3 is what we do first, which is giving us 6, and that's going to be to the power of 2, which is 6 times 6, giving us 36. So when you have an exponent on a bracket over here, and there are operations that you can do inside of the bracket, that's what you want to do first before you square it out. And basically that is exponents. Obviously we can always do what you call it, which one is bigger and which one is smaller. So 8 squared and 9 squared, they increase with the numbers, so 9 squared will always be bigger than 8 squared. So we will always have, if the base is bigger, then the whole number will be bigger as well. This is different for fractional bases, so if you have something like half squared and quarter squared, but I don't think you will do that in primary school. Right. So they can ask basically 2 or 3 ways, 3 different questions that they can ask you. They can ask you to calculate doing something like this. They could ask you to write in expanded notation. So to write an expanded notation just means to write it as like 2 times 2 or 3 times 3 times 3 or whatever the case may be. So if we have something like 8 cubed, then the expanded notation would be 8 times 8 times 8. If you have 81 to the power of 5, then the expanded notation will be 81 times 81 times 81 times 81 times 81. And that's it. Obviously, they're not going to expect you to calculate 81 to the power of 5 without the calculator. But this is just how you do expanded notation. If they do give you something like, let's add in some algebra quickly. So x to the power of 7. As I said earlier, letters work exactly the same way. So that's your x over there. Just not to get not to be confused with the multiplication sign. So 1, 2, 3, 4, 5, 6, and 7. So that is expanded notation. Also, you can determine squares. So you can determine the square, like 3 squared, which equals to 3 times 3, which is 9. That is another way they can ask questions. They could ask you to write it into exponential form. So write in exponential form. Another way they could say is to write in power form. A power, this is a power over here. So, which is a base to the power of exponent, that is a power. The term power is not used as much in high school, but just for interest's sake, if they do use the power in your exam, or the word power in your exam, they're just asking you to write it in exponential form. So if they do give you something like 60 times 60 times 60, in exponential form, we obviously just take the base. It's the number that is being multiplied repeatedly, which is 60. And then we count how many 60s are there. There's 1, 2, 3. And there's your exponential form or your power form. And yeah, that is basically exponents. Now, exponents can also work in the opposite way. So if we have, let's take, for example, 16, right? And we want to know, well, what are the factors that, what are the two numbers, the same numbers, that when you multiply them together will give you 16? And this is where square roots come into play. So the square root is the opposite or the inverse of square numbers. So we know that 16 is 4 times 4, right? So we can then say that the square root of 16 is 4. It's the number that you need to multiply by itself to give you 16. 25 is 5 times 5. So therefore, if we take the square root of 25, it's going to equal to 5. So the square root is the opposite of a square. We know 25 is a perfect square, so when we take the square root of a perfect square, it's going to equal to the number that needs to be multiplied by itself to give you the perfect square. If you wanted to, you can also do it like this. So let's take 36, which we know is 6 times 6. So for the square root of 36, this is going to be square root of 6 times 6, because we know that's what 36 is. And 6 times 6, we know in exponential form, is 6 to the power of 2. So this will be 6 to the power of 2 under a square root. Now, as I said, a square root and a square are opposites of one another. Opposites in math, or inverses in math, they tend to cancel each other out. For example, plus and minus are opposite of one another. So if we have something like 3 minus 3, it's going to equal to 0. So same thing over here. A square and a square root will cancel each other out, leaving you with a number 6. I'll show you that again. Here with 25, this is going to be 5 times 5. And 5 times 5 is 5 squared. So take note, I'm only changing things under the square root. The square root stays as is. And since we have a square and a square root, they cancel each other out, leaving you with just the 5. So a square root of a perfect square is just equal to the number that you need to multiply by itself. So 5 times 5 gives us 25, 6 times 6 gives us 36, 4 times 4 gives us 16. I'll repeat once again, multiplication tables extremely important. So if you know that 16 is a perfect square, then you'll know that 16 can only be, you can get 16 by multiplying 4 times 4. You can get 36 by multiplying 6 times 6. And this applies to all the squares and also cubes. So 3 cubed, which is 3 times 3 times 3, is equal to 27. So 27 is our perfect cube. So if we take the reverse of that, which is cube root, and we put a little 3 on top over there. So the 3 just signifies cube root. So when we take the cube root of 27, this will then be 3 times 3 times 3 underneath the cube root. And we know 3 times 3 times 3 is 3 cube. And similarly, like square roots, cube roots and cubes, this to the power 3 over here, this is a cube and this is a cube root, so they cancel each other out, and you're just left with that base over here, which is 3. So this here is cube roots. So this is just the opposite of perfect cubes. Okay, and they can obviously ask you different ways to calculate square roots and cube roots. They could ask plainly just what is the square root of 49. So 49 is 7 times 7. 7 times 7 is 7 squared. And we know square and square root will cancel out, so the answer is 7. You don't have to write this step over here. Once you know that 49 is 7 times 7, we can already see that this number is being repeated, so that is going to be our answer over there. Excuse me. There can be calculations underneath the square root, so something like the square root of 30 plus 6. Now when it comes to calculations under the square root, when it comes to adding, you have to add or subtract. So 30 plus 6, you have to add those two together to give you 36. And 36 is a perfect square, which is 6 times 6. And that answer is just going to equal to 6. So you have to add first before you can take the square root. Same thing, yeah, multiplication. 8 times 2 is 16. So yeah, what they're doing is they're taking another set of factors for 16, which is 8 and 2. But you have to know that 16 is a perfect square, which we can write as 4 times 4, which gives us the answer of 4. So when it comes to calculations under the square root, you have to do those first. But be careful. When we have two perfect squares underneath, so for example 9 and 16, like that, you have to add those two, which gives us 25, and obviously that's going to be 5 times 5, which equals to 5. But when they are multiplied by each other, two perfect squares are multiplied by each other, you don't have to actually say 9 times 16. You can actually write them separately with their square roots. Only do this for perfect squares though. So the square root of 9 would be 3 times 3, and the square root of 16 is 4 times 4. So now we know that the square root of square root of 9, which is 3 times 3, is 3, and the square root of 16 is 4, and 3 times 4 is 12. So yeah, that is square roots. Can you do square roots? Can you multiply square roots together or add square roots together? Yes, you can. So we can take something like square root of 81 minus the square root of 16. The square root of 81, that is 9 times 9 under the square root, and 16 is 4 times 4. So square root of 9 times 9 is 9, minus the square root of 4 times 4 is 4. So 9 minus 4 is then 5. Square root of 81 minus the square root of 16 is equal to 5. And we can multiply square roots as well. So let's take 64, that's what I want to write. Multiplied by the square root of 49. So square root of 64, that is going to be 8, and for 49, that is 7. So that's 8 times 7, which is 56. So we can multiply two square roots together as well. Now this is obviously all simple ways to do this. So let's take a question from an actual exam and we try to calculate those. So this question comes from an actual exam, and you can see they are mixing exponents and square root and cube root together. This is all fine because we work with them separately. So it's not that difficult. 6 squared we know is going to be, and we'll write all of these out in expanded form. So 6 squared will be 6 times 6. And then we have 10 cubed, 10 to the power of 3. This is going to be 10 times 10 times 10, and I'll show you now how to do that. Minus square root of 49. So 49 is going to be 7 times 7. And then square root of 1, which is just going to be 1 times 1. 1 is a very special number in that when we multiply, when we do exponents and roots on 1, it stays exactly the same. I showed you earlier on, where is it? Oh, apologies, that just closed down. I hope it's saved. Here we go. So here I showed you how 0 to the power of anything is 0 and 1 to the power of anything is 1. We can do the reverse of this as well, where we take the square root of 1, which is just going to be 1. It can take the cube root of 1, and it's still going to be 1. You can take the 1,000th root, is what we call it, of 1. It's still going to be 1. It doesn't matter what you do to 1, it's still going to be 1. So whenever you see 1, most of the time it's just going to stay as 1. Right, so we expand everything. So now let's calculate. That is 6 times 6 is 36. And whenever you're multiplying 10s together, all you need to keep in mind is the zeros. So how many zeros are being multiplied here? That's 1, 2, 3 zeros. So 1, 2, 3 zeros. And since all of them are 1s here in front, you just put the 1 down over there. Obviously, it's going to change if there's other numbers over here. Like 2, 20, 20, 20. It's going to say 2 times 2 times 2. In this case, it's 1 times 1 times 1, which is just 1. And then add the zeros over there, which is 1, 2, 3 zeros. And that's how you do 10 to the power of anything. Let me just do another example quickly here on the side. So if you have 10 to the power of 4, this would be 10 times 10 times 10 times 10. So how many zeros are being multiplied? 1, 2, 3, 4. 1, 2, 3, 4. And then it's 1 times 1 times 1 times 1. And as I said, 1 times 1 will always be 1. So you just put the 1 there in front. So if it is something like 20 to the power of 3, which is 20 times 20 times 20. How many zeros? 1, 2, 3. 1, 2, 3. And now I just go 2 times 2 times 2. 2 times 2 is 4. And 4 times 2 is 8. And there you go. So that's how you work with zeros as your unit. Going back to this question, 6 times 6 is 36. And 10 times 10 times 10 is 1,000. I'm going to subtract this over here. When you see brackets, brackets mean it's like a gate basically. This gate can only open once you are done with the operations inside of the brackets. So here we have the square root of 49, and the square root of 49 is 7. And here we have the cube root of 1, and the cube root of 1 will just be 1. So 36 plus 1,000 minus 7 plus 1 is 8. That's the last of the operations. So you just put your 8 down over there. So you see how the brackets fall away. And now we just have to do these together. Plus and minus, in terms of BODMAS, we can see addition and subtraction here, those are together. So it doesn't matter which one comes first. In this case, we can just add them and subtract them in whatever order we want. So if you want to add those two first, that's fine. Or if you want to subtract those two first and then add, that's completely fine as well. But we'll do it in order. So 36 plus 1000 is 1036, and we then have to subtract 8 from that, which is then going to be 1028. And there we go. So even though they are mixing exponents and roots, exponents and square roots and cube roots, we can still calculate them separately and then add and subtract or multiply and divide, whatever the case may be. So let's look at some other examples quickly. Let's do something a bit more challenging. So this takes everything that we've done this week into account. There's some squares, there's some cubes, there's fractions, there's mixed fractions, and we're going to use everything that we've learned this week to answer this question. As we said before, brackets, we have to work inside of the bracket first, so that is what we're going to do. And I'm going to continue using expanded notation just so I can see how we are calculating this. So for the 4 squared over here, that is going to be 4 times 4 minus 2 cubed, or 2 to the power 3. That's going to be 2 times 2 times 2. Don't forget your brackets. Keep them as is until you are done calculating everything inside. Divide. Here we have a mixed fraction, and try to not work with mixed fractions. We like to work with improper fractions. So we're going to change this to an improper fraction. And how do we do that? We take the whole number and you multiply it with the denominator, and then that answer you will then add to the numerator. So 3 times 8 is going to be 24, and we must add that to the numerator. The the denominator will stay exactly the same. Plus 7 over 8 to the power of 2. We'll work with that to the power of 2 in a second. We just want to work with inside of the brackets first. So yeah, 4 times 4 is 16, and then 2 times 2 times 2. 2 times 2 is 4, and then 4 times 2 is going to give us 8. Inside of the second bracket over here, 24 plus 1 is 25 divided by 8 plus 7 over 8 to the power of 2. 16 minus 8 is just going to be 8. And that's the last of the operations inside of the bracket, so the brackets can fall away. Then we divide. Over here we have 2 fractions that are being added together, and since the 2 are being added together, the denominators here are the same, which is great. So we just keep the denominator and we add the not exponents, and then we add the numerator. So 25 plus 7, that is going to give us 32 divided by 8 to the power of 2. So 8 divided by 32 over 8. Let's look at the multiples of 8 and see if 32 is a multiple of 8. So 8, 16, 24, 32, 40. We can see there's our 32. That means 8 can go into 32 1, 2, 3, 4 times. So 32 divided by 8 is 4, and that must be squared. So now we have 4 squared, and 4 squared is just 4 times 4. Now we'll put this in a bracket. So 4 times 4 is 16. So what's 8 divided by 16? We know that when we have division over here, division can be written as a fraction. So this can be written as 8 over 16. And 8 and 16 are multiples of 8. So we can divide both the top and the bottom by 8. So 8 divided by 8 is 1, and 16 divided by 8 is 2. So there we go. We used everything that we did this week regarding fractions and exponents to answer this question. So it's a good question, mixing everything that we did, and we got to the answer of a half. Nice. Okay. There is one more question. This is quite a big question. Okay. 60 minus 4 to the power 3 minus the square root of 576 plus 49 plus 8 minus 4 squared divided by 8. So this is going to be 60 minus 4 to the power 3 is 4 times 4 times 4 minus, here we need to add, so 576 plus 49. This is going to be, excuse me, 576 plus 49 is going to equal to 600, and that's going to be 625 under the square root, plus here it's going to be 8 minus 4 squared is 4 times 4, and then we have to divide by 8. Okay, so 60 minus 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64. Minus the square root of 625. That is quite a big number. The square root of 625 is, let's just use the calculator. So let's see what that's going to be. There we go. So the square root of 625 is 25. So this would then be 25 times 25 plus 8 minus, and 4 times 4 is 16 divided by 8. Okay. $60 minus 64 minus, and we now know the square root of 625 is 25 plus, and in the bracket over here we have division in the second part over here, so we have to divide first according to BODMAS. So just a side note, how BODMAS works is brackets of division, multiplication comes first, and then addition, subtraction. Now with division and multiplication, it all depends on what comes first in the line. If multiplication is first, then you have to multiply first and then divide. Similarly with addition and subtraction, if you have to subtract first before you add, then you can do that. Then you have to do that. But it's more important with multiplication and division. Take note of what comes first. In this case here, inside of the bracket, there is only a division, and division comes before addition, so we have to divide first. So this has to be done first. So it's going to be 8 minus, and 16 divided by 8 is 2. Alright, so that's 60 minus 64 minus 25 plus 8 minus 2 is going to equal to 6. Okay, so if we put this, so if we calculate this, we're going to find that the answer is a negative number, and I don't think that the grade 7th has done negative numbers yet, but you will be doing it later in the year. What do I mean by a negative number? So these two numbers over here, they have a plus in front of them, and these two numbers over here, they have a minus in front of them. So if we were to add the two purples and the two yellows, let's say purple will give us 66, and 64 and 25 is going to give us what's that, 89. So the 89, there's more negative 89, there's more negatives than there are positives. So you'll find that your answer is going to be what we call a negative number. So I'll show you on the calculator what's going to happen. So if we say 60 minus 64 minus 25 plus 6, you'll see that the answer is going to have a minus sign in front of it, like that. So you'll see there it is minus 23. I'll do it like that. So the answer there is minus 23. So this is just a little teaser of what you will be doing later in the year, which is called negative numbers. This is where I'm sure on the number line you'll have 1, 2, 3, but on the other side of the number line you have what we call negative numbers. That is for later in the year, if not now in the third term. But there you go. Despite the last part over there, I'm sure you understand everything else. How to determine a cube root, how to do square roots, BODMAS. We did some BODMAS here as well. Turn this off. And yeah, that is basically what exponents are all about. Everything that we've done this week is quite important for high school. So if you can understand this in grade 7, then grade 8 and 9 and 10, 11 and 12 will not be that difficult for you. Yesterday and today, I'm going to leave you once again with the same message that I said yesterday. Multiplication tables, extremely important. Do try to learn them, and even if even in normal life, because that's what students always do. Where do you use math in regular life, in normal life? The multiplication tables is something that you will use all the time outside of school. So know your multiplication tables, your squares, your cubes, exponents, are just basically a smaller form of multiplication, repeated multiplication, I should say. So do try to memorize those, because the calculator can only help you so far, and you don't always have a calculator. No, let me not say that. um, I'm just preparing you for later on in high school. But that's going to be us for today. Revise. Try to revise as much as possible. Practice every week, and it should make your exams a lot easier, because you won't be stressed studying before your exams. So revise, know your multiplication tables, and if at any point you need help, ask questions, ask your teacher questions, ask your friends questions, ask them to explain to you if you don't understand. And if they can't help you, tell your parents, if parents you are listening, but tell your parents, get a tutor. Nudge, nudge, wink, wink. We are obviously a tutoring company, but if not us, it doesn't matter who you go with. Get yourself a tutor. They can help you through math, they can help you through other subjects if they are able to do it. But don't be afraid to ask for help, don't be afraid to ask questions, because I'll say it, math is not the easiest thing to learn. So don't be scared to ask for help from your teachers, from your friends, or from some other people that know what they are doing. Thank you very much for taking the time to watch us this week, grade 7s. We will try to do more of these later on in the year, like exam revision before obviously your September exam and your final exam for the year. We'll try to do those. No promises, but that is going to be us. Next week it's only high school work, so enjoy the rest of your holiday, and I wish you guys all the best for term 3. Have a wonderful